All right, can you guys hear me now?
Yes.
Yes.
Okay. Well, I think
Yeah, now it is good.
whatever happened. Okay, so let's continue here. All right. So what was the question again? Okay, let's go back here. All right, so it's referring to question 7. And question 7, let me just give that to you guys, is about compiled, right? Compiled languages, right? Compiled languages. So it's just all you have to do is just remember these definitions. There are a lot of definitions, obviously, to remember, but you can see right here where it says compiled languages, the source code is compiled once and then executed many times. So that's what we have in that question, question 7. What type of high-level programming language is translated into machine code once and then executed many times? Compiled. Let's just confirm that. Question 7. Chapter 6. So right there, compiled language programs are compiled once and then executed many times as needed. Scripted languages and markup languages are interpreted languages which are not compiled. So scripted and markup are not compiled. Okay? All right, let's go back here. All right, question 8. All right, here's another one that you need to know the definition of. A programmer wants to write code that directly accesses a computer's hardware. That is, the code is going to affect or going to cause some kind of response from the hardware. For example, you can write code that affects the keyboard. You can write code that affects the mouse. You can write code that affects the monitor. You can write code that affects the printer. Hardware, right? The code affects the hardware. Okay? So it says right here, which is the best type of language for the programmer to use if you want to write code that's going to sort of have an effect on the hardware?
Assembly.
The hard drive. Say it again.
Assembly.
Okay, so let's see what assembly is. Assembly. All right, so right here, any programmer writing code is telling the computer, specifically the processor, what to do. So, and that's what it says right here. Assembly language is the lowest level of code that people can write. It allows the developer to provide instructions directly to the hardware, right? Directly to the hardware. It says it's translated into executable machine code by a program called an assembler. Okay? So that's all you need to be concerned about. You don't need to know all the details. But if you see the question about assembly, you know that that kind of code, you write it when the developer or programmer wants to provide instructions directly to the hardware. When you move the mouse, this should happen. When you press the keyboard, this should happen. When you put a CD in the CD drive, this is going to happen. That code, for example, this code that I wrote here, right, this doesn't affect the hardware, right? This is just software. This works in the browser, right? It doesn't affect the hardware. But when you write code, you know, some of those codes look very complex. that affects the computer itself, then you can say that that is more assembly code. So that's right. That is assembly right there.
Thank you.
Okay. So this is quite interesting. This part here, Alex, if you remember, we talked about it. So part of programming, right? We refer to part of programming as conditional statements, right? Conditional statements are statements that work, or some code that work depending on the situation, right? If something happens in the code, then something else is going to happen. If this happens, do this. If it doesn't happen, do the other thing, right? We call them if-else statements. If this happens, then this should happen, right? If the mailman comes or the mail carrier comes, give them a bottle of water, right? Because it's a hot day. If they don't come, well, throw the water away, throw the bottle of water away, something crazy like that. So a conditional statement. If this person is this age, like the program we looked at the other day, right? If you guys still have the program, I have it here, I saved it here somewhere. Okay, you guys still have this program? Let me put the link in the chat. Sam, we created a fake website. Let me put it in the chat so you can see what it is.
That's great.
So the link is in the chat. So if you click the link, you're going to see it there. So conditional statements in your code, it tells you if based on a certain condition, the program is going to respond in a certain way. Okay, so from what we did, if you enter your name and say the name is Greg, now this is it's going to check your voting eligibility if you're eligible to vote. Sam, this is just a fake website that I created myself just to demonstrate, this question here. So it says you have to be 18 to vote. So if Greg comes here and Greg says, well, I was born in 2012. Am I eligible to vote? Well, let's check. Check. Says, oh, sad face. You are 9 years old. Get out of here. You should be in kindergarten or something, right? You're not eligible. Now, if somebody else comes there and says, well, my name is Amali. Amali says, well, I was born in 1998. Am I eligible to vote? Check eligibility. Says, hey, Molly, you can vote. So there are certain conditions built into this program, okay, that determines your age. And depending on your age, it will tell you if you can vote, and it will give you a smiley face or a sad face. So a lot of conditions built into the program, right? It's a fake website. It's not fake. I mean, it's not like a government website or anything. It's just to demonstrate. Okay, like I said, I spend all my time coding, so I do all kinds of crazy things. So back to the question. Lynn, the question is for you. Lynn is looking completely bored, like, I need to get out of this class right now. So Lynn, this question is for you. Number 9.
Interpret is the following logic.
Logic, basically this code, right, Lynn? All it's asking you is, look, read this code and see if you can answer the question, what this code is saying. What is this code saying, right? So if you're 20 years old, right, what's this code really saying? So if you look at it line by line, let's look at it line by line. First line here says what, Lynn? What's it say here?
If age greater than 30, then
wait. This symbol is what?
great more.
The opposite.
Oh, less than. Sorry,
Okay.
I made a
All right.
mistake. Yeah, less than
Okay,
13.
all right, so do it again.
If age less than 13, then category child.
Okay, so if the age is less than 13, then you have this category child. Okay, next line.
Else if age less than 20, the category teen.
Okay, keep going.
Else if age less than 65, then category adult. Else,
Adult.
else category senior.
So do you understand what he's saying here? There are 4 categories depending on your age, right, Lynn?
Yeah.
Okay, so the question is, someone who is 20 years old, what's their category?
Someone who is 20 years old, second, no, third.
Which one?
Third.
First line, second line, is it child, teen, adult, or senior?
Adult. Teen.
Why adult?
Less
Why
than,
adult?
less than 65.
Less than 65, right?
Mm-hmm.
Yeah, you're right. Is Lynn right?
Yes, yes.
Yes.
No.
Yes, I agree.
Yes.
Yeah, because less than 13, if you're age 1, 2, 3, and all that, you're going to be a child. If you're less than 20, so you're more than 13, but less than 20, you're a teen. More than 20, less than 65, an adult. And if you're over 65, then you're a senior.
Yeah.
Do we have anyone in this class that is in the first category? Anybody here? In the first, I think Couch has somebody who is in that category.
Me kuda.
Somebody in Couch's house is in that category, right? Okay.
3 in that category.
I have 3 in
Oh,
that
3 of
category.
us. Oh wow. Okay. Your hands are full. Okay, great. All right. So that's how to read. What we call conditional statements, right? When you see, or you can call it a logic. Basically, saying, look at this code and see if you can figure out what is talking about. Okay. All right. Let's keep moving. The next one we have here, I know this for you. Number 10.
Yeah, sure. A programmer is writing a program that needs to accept an input of someone's name. What type of variable should the programmer create? A name should be a string.
Okay, so remember we talked about data types. Okay, data. Let's see if we can find data type. Okay, so right here is your data types that are used in programming. Okay. The other day we talked about some examples and we said things like data types. Okay, let's just use what we have in the book here. So we have char or char, right? Character, string, integers. So characters are literally any character, right? Any character at all, right? A or B or C or whatever. Any character that you type. In fact, everything you see on the screen right here is all characters. So any character, right? A string is more than one character. I don't know how 0 can be a string actually. It says 0 or more. How can 0 be a string? A string has to be a couple of characters. So usually strings will be names, addresses, places, you know, things like that. Words will be strings. Integers are numbers. Floats. A float has a decimal, 5.2, 3.5, 5.000. It's called a float. A float and an integer are not the same. An integer is a whole number. A float is a decimal, right here. A float is a decimal place. So if you see, so right here, 5.0 and 5, the first one is a float because it has a decimal point. And the other one, 50, that is a whole number because it has no decimal places. All right? Then there's something we call Boolean. Boolean is if you have true or false, yes or no, right? True or false. That's usually when you have a Boolean situation, Boolean. So, and back to the question, I think you're right. If you're trying to write somebody's name in your program, the input is going to be string. Okay?
Yeah. Yes.
Excuse me, Banjo.
All right, very good.
Excuse me, Banjo. Char also is used for name.
But it is a
Say
single
that again?
character. Character is for single character.
Yeah, character is like a single character, just one character.
I
Okay.
think it's character.
Okay.
Oh, so the answer is string, not this one. The answer is string for somebody's name. Okay, let's go on. Number 11. Couch, this for you.
Okay. Looping logic makes use of which of the following statements? Loop. Why, when?
Couch, I can imagine what your answer is going to be, but let me wait for you to select it.
Okay.
Is it A, B, C, or D, Couch?
See?
So you guys heard what I said, right? I said I can imagine what Couch's answer is going to be, and that was exactly what you selected. Loop. There's nothing like loop. Loop is not a logic. Loop is what happens when the program is running. Loop is what happens when the program is running. So let's see what the answer is anyway.
While
Let's just see what the answer is.
Statements looping logic.
Where is it?
If
I think it's
Let's see what the answer is.
While.
yeah,
Question
while
11.
A.
See that right there, a while statement. Okay, so let me show you what that is. Because the other day I tried to build some code, but I didn't get it. We didn't complete it. So I'm going to show you right now. So let me send you this file. I thought I had it here somewhere. Let's see. Okay, so let me send it. Let me put this in the chat. You guys can take a look at this. So look in the chat. So, Couch, tell me what you see in that. When you run that, do you see what I see here? Like, it's running "Hello World, Hello World, Hello World."
250 times hello world.
250 times, right?
Yes.
Okay. So, where is that here? I thought I had it here somewhere. While loop. Okay. So, you don't have to understand all the code, like I said, but here's an example of looping, right? You can see in this program that I have here, it's using a while statement. While. Okay. Now, if I change this to 1,000, see what it's saying here on line 22 is count number limit. Count number limit is 0. So if while count number limit is less than number limit, right? So while 0 is less than 1,000, it's going to run until 0 becomes 1,000. So we have something that we added here on line 25. It's like a counter. Every time you run the program, it becomes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It keeps running, right, until it gets to 1,000. If you don't have a counter there, it's going to just keep running forever and crash the program. So that counter, right, that counter, it's like when you wake up in the morning, then you go to bed at night. You start, and things have to start and end. Nothing just goes on forever. It starts and ends, starts and ends. So a while program needs a counter. So you keep increasing the number. So let me run this one here so you guys see the result. Let me just go up here to my upload site. All right, where is it? Okay, so let's see. So remember what I did here was 1,000 times, right? So let's see what happens here. How many times did it do? It keeps going. May, do you see this? It goes to 1,000.
Yes.
So the loop is going to keep going. If I set it to 1 million, right? Is it going to work?
System will keep running for 1 hour.
It's going to keep running forever. You guys, should we try it out?
No.
Let's try. Let's see if it works. Okay, here goes. But did I don't think I saved it. I need to save it. So let me save it. All right, so go back here, upload it. All right, so let's see, run. So it's running. It's going to take like a while for it to be done. Now let me go here. Actually, it's going to slow down the system, right? So let me just stop it. It's going to slow everything down. That's a lot. So back to the book. So that's what it's referring to there in terms of, what's the question? In terms of a looping logic, right? And if we look at what the book says here, okay, you can see right here the two main ways that programs perform logic are branching and looping, right? The branching is, if else, that's branching. But the looping is what we have here. Where is that? Right here. They use an example of traffic light. While the stoplight is red, stop. Otherwise, go. While the light is red, you keep repeating the loop until the condition changes. So you use while. The while statement is used for looping. Okay? So that's an example there. So if you see that, you don't have to know how to create the code yourself, but you should have an idea of what it's referring to in a programming language. So Kaush, the answer is not loop. Loop is what it does. The answer is while. Right? So loop is what it does. It loops, but there's nothing like looping. You know what I mean? It's just the logic, the idea.
So was that job? Were we looking at JavaScript or were we looking at something else?
No, this is not JavaScript. This is PHP.
Oh.
This is PHP. So the chapter talked about PHP as one of the scripting languages, right?
Mm.
PHP. So yeah, PHP actually works with databases, right? So, you know, yeah, a lot of programs use databases. So if you want to save your username and your password and log into your account, PHP is used for that. In fact, let me show you guys this. I don't think I ever talked about this. So this website here, let me send you guys the link, put it in the chat. Okay, if you look at this website was built using PHP, right? And you can go in there and create a free account. It allows you to store, you know, important things, attachments, notes, information privately. There's a lot of security behind it, right? It took about, let me see. It took about, I think, about 7 months to build this site, and it's still continuously being developed, right? It's called iBot. It was built in PHP, and you know, PHP is a very powerful program that can help you, if you learn it, accomplish a whole lot of functionality on, you know, on a website. So feel free to go in there, create a free account. A lot of my students use it. I use it myself. Okay, well, let's get back to the book. All right, so yeah, so Sam, to your question, that was written in PHP.
Oh, okay.
All right, question 12. I think I talked about this already. Attributes and properties. In object-oriented programming, which of the following are integral parts of objects? Objects. This is all part of programming, but let's just take a look at it. So right there, objects. Okay. Okay, right here. So right here, this section, it says, objects are collections of attributes, properties, and methods that can be queried or called upon to perform a task. Right? Objects are a collection of attributes and properties that can be called upon to perform a task. For example, this example, when we looked at this here, where was, I think it was, yeah. So when we did this example, style here is an attribute, and then we have color. So we needed to use these attributes and properties to help us get the color for the text. Okay, without this attribute and properties, the hello has no color. But when we include the properties, the attribute and the property, that is, like I said, the attributes of an object, you know, it helps you, like it says here, it helps you to perform a task. Okay? So an object can be a variable, a function, a method, data structure. In this case, we're dealing with styles, colors. Okay? So that might be important for you to know. Objects have properties and attributes. Like we said here, those things help you perform a task in your code. So let's go back to the question. So that's just all you need to remember there is number 12, attributes and properties, right? Properties. Okay. Question 13. May, are you there? This should be an easy one for you.
Yeah. 13.
Question 13.
program shows the number 1101.0.11. So which data type is this? Is the float
A, B, C, or D?
D?
C?
D.
C?
D. Last one.
Oh, the last one. Float.
Mhm.
Yeah, because it's a decimal number, right? It's a decimal number, and so it's float. It's decimal.
Yeah.
Okay. All right. Well, this part, this number question 14, this I'm going to ignore this because this is just going to be, this can be confusing, right? So, yeah, because when you talk about arrays, there's so much detail in that particular topic. All right, and I don't want to add, I'm not going to talk about it because it might just be very confusing. So, if you read the book, you might be able to get an idea of what it's talking about, but some things are just, in my opinion, not worth even talking about. So we're just going to skip question 14. You can see the answer there if you go to the answer, but let's just ignore it. Question 15. This is important. Question 15. Let's see who hasn't answered here. Anu, let's go to you.
Yeah. What type
Actually,
of?
wait a minute. Let's go to Alex. Let's go to Alex.
Okay.
I don't want to forget anybody here. Alex, try 15.
What type of programming language is designed to retrieve data from a database? Query, assembly, interpreted, or I would answer letter A.
Okay. So let me do this right. Let me go back to this program I just showed you guys, right? So I'm just gonna log in here. All right, so here's an example of what I'm talking about. So let's say I go into this iBot program, right, Alex, to create, it allows you to create notes. So I'm going to create a note. I'm just going to say, classwork 6/23/2021. Okay? I'm going to say, talking, I don't know, let's say CompTIA lecture, something like that, right? Just a random note. Now I'm going to save this note, right? I'm going to save it. So I need to find the note, right? I just saved it. I need to find it. So I'm going to do a search. Now I know the title. Alex, what was the title of the note again? What did you write as the title? Anybody remember?
You put a date, but
yeah, like a date, right? So I know today. I put today's date. So I think I put 6, right? So look at that, right? When I do a search in the program, if I remember something in the title, this is what we call the title, right? 6/23/2021. I click on search, and you see it pulls up the note that I created. And if I click on that, that's the note I created. I can go in there and edit the note and add some more and say, CompTIA lecture, say Sam was here, right? So I add some more information to my note and I save the note. Okay? Now, if I don't want to search, I can just scroll down, keep scrolling until I find the note. It's right here. You see that? It's right here. And you can see the date that we saved the note. It was today at 2:14, right? So the question is, where did this save, Alex? Where did this information save, and how come we can find the note again and all that stuff? Where was it saved?
Probably in a database.
Yes. It is saved to a database, right? And so you can save to that database, and if everything is designed correctly, you can find whatever you save to the database, you can update it, right? So the query language is a very useful and important language in programming. You have your email account, your bank account, your Facebook, your Twitter account, your school account, your Canvas account. Every time you have to save something and go back there to get it, it's saved to a database. And database languages are right here, query languages. A query language is most generally always in SQL, called SQL, right? Referred to as SQL. Now, if I go back to W3 Schools, this website, it's a free website. They have a lot of tutorials about it. But here's an example of what SQL might look like. So right here, you can see that it says here, select from customers. What does that mean? You have a database that has a lot of information, like when we looked at Excel the other day, right? We went to Excel and we created a kind of a list, say name, date of birth, email, just as an example, right? John, Mark, say date of birth is 2/3/1998, email jm@gmail.com. Just a random thing, right? So if you have a database like this, and you have a lot of users in there, right? Every time a new account is created, it gets saved in the database, right? When you want to log into your account, it's going to ask you, it's going to check the database to see if your account information is correct and put it out for you. Or like we did here, if you save information in the database, it can retrieve it. The language for that is SQL, right? SQL is what you use for that, and that's what it says in the book. So it's a query language, right? Structured query language, SQL. If you use Microsoft Access teaches database like it's fantastic. If you use Microsoft Access, if you enroll at Quincy College, there's a lot of courses where you do work in Microsoft Access to teach you how databases work. You know, how you save, customers' information, you save payroll, and you can retrieve that information. Right? When you save it, you can retrieve it. So that question there, Alex, it says what? What's the question again? So what type of programming language is designed to retrieve data? Right, it's a query language, you're right. It's a query language that's used for that purpose. And the most common query language is SQL. And that's what was used also on this iBot website, right? And, databases can save a lot of stuff. Can save pictures, can save text, can save files. For example, if I edit this here and I want to attach a file to it, say I want to attach, right? I go to browse and let me look for just some random stuff. Let me see. Let me just get this random file, attach this file here. So that file is attached. If I save the file and then I go look for it like I did earlier, I think I put 23. All right, right there. The file I saved, just some random file with Wi-Fi information, right? Just a random picture file, but it's right there. So databases powerful, can save a lot of stuff if it's well designed. Okay? So you're right there, Alex. That's query language. Let's go to the next one. All right, so again, this is something similar to the other question that we had. May, you want to try this? May?
Yeah.
So right here it says a law enforcement agency has received data indicating there are 10 current threats to public safety, right? 10 threats to public safety. So basically, there are different colors, right, for the different threats. You know how you go to the airport and it says, oh, the threat level is at this level or whatever it is. So the question is, what should the threat level be if there are 10 current threat levels? So may try this. What color is it going to be?
Red.
Yes.
Why red?
Is less than 12.
Okay. So less than 12 tells you that so more than 9, less than 12. Okay. It tells you it's red. Okay, very good. And Juman, you want to try number 17?
Yes. 17. Which of the following is an example of a markup language? Which of the following is an example of a markup language? Java, Python, XML, SQL. Example of a markup language.
It looks like HTML, right? And Juman, it looks like HTML. Let's see what that is. Let's see what that is there. Right here. So you see that, Anjuman? It says it's XML. XML is an example of a markup language. The other markup language is HTML. Right? So XML is just, it looks like HTML, but it's not exactly HTML, but it's also a markup language. Okay? So that's what that is there. XML. Okay, next question. Where's the question here? Okay, let's see. Okay. Art, you want to try this?
To understand the square of a program.
You want to understand the sequence of a program from start to finish. Which of the following is the best to use for this purpose? Flowchart.
Flow chart. Let's see what a flow chart is. Flow chart. All right, so flow chart. Here's an example of a flow chart, right? A flow chart is kind of like Arch, do you know what this is?
Plan.
Yeah, like a blueprint, a plan to build a house, right?
Blueprint.
Yes.
So a blueprint, right? You're going to have the master bedroom here. You're going to have the bedroom here, the kitchen, the bath, right? It tells you where to put everything, okay? Where to put everything. You can always make changes, but before you build a house, you can make changes to the plan. After you build a house, it's kind of too late, right? So before you build a house, you can make adjustments here. So that's kind of like what your flow chart does, right? It says that the flow chart is a visual representation of a program, right? It uses boxes to, okay, and here's the example right here. It uses boxes to tell you where everything is going to be at, how the program is going to run. Okay? That's what a flow chart does. It tells you how the program is going to run. It starts here, then you have to declare some variables, then you put some values. If this happens, it's true. If the other thing happens, it's false. If it's true, it's going to display B. If it's false, it's going to, a flow chart, like a plan to help you organize your program, just like a blueprint. Okay, just like a blueprint for a house or building. So you're right about that. All right. Well, we got two more questions here. 19. I know you want to go back to this one, 19.
Okay. Which of the following programming language types is the lowest level language? Assembly language is the lowest level language.
Yes, because that's what we said about assembly, right? That it's the lowest level, and you write assembly when you want to talk to the hardware. All right, right there. It says assembly language is the lowest level of code in which people can write. When you want to write code that gives instructions to the hardware.
So
okay?
Can I ask a question?
Sure.
For the drivers, do they use assembly language for that? Or how do they?
That's a good question. I never really thought about that, because drivers help your hardware to communicate with the computer. Right. So I actually never thought about it. It sounds right. It sounds like you might be right about that, but I can't give a definite answer.
Okay.
But it sounds reasonable to think that, yeah, that's what drivers do. They help the communication. I mean, they provide instructions directly to the hardware, right? So
yeah.
So you might be right, but I have to do some digging.
I'll just Google it. Let's see if I can Google it.
Yeah. Yeah, go to Google, right? Actually, let's go. We have a couple of minutes here. So let's say drivers, assembly. Somebody has checked that already. So let's see. So how assembly language is used in device drivers? Okay, right there, you see? So device drivers are typically written in C. Yeah, and C isn't that what is used for assembly language? I think a lot of assembly language is written in C, right? Let's see. Assembly. Okay, I'm not seeing that information here, but I think I read that. But let's go back to that. Let's go back to that definition here. So the functional object-oriented ways to program drivers depending on the language chosen to write it. It's generally not possible to program a driver in Visual Basic or other high-level languages. Okay, so right here. Assembly language is used primarily for direct hardware manipulation, access to specialized processor instructions. Yeah, so I think you're right. I think you're right, Sam.
But C is not an assembly. C is not assembly language, is it?
Yes, C is not an assembly language.
Is procedural or
so it's not written in. Okay, well, we have to do a bit more digging into this one here, but that's actually a great question. Right here it says most drivers are written in C or C++. Okay. All right, so they're writing in C++, but assembly language is not written in C++ or C at all. Anyway, we got to go on. So one more question I think we had. So the answer there anyway is assembly for that last one. Let's go all the way down. All right, and then the last one here, flowcharts depict which of the following: programs, objects, functions, identifiers. So if you go back to, let's just see what the answer is. Because we just looked up flowcharts now. And the last answer there.
Functions, maybe.
What did I click on? 6? All right, a flowchart is a visual depiction of a program. It includes the logic components, inputs, and all other properties of the program. Visual depiction. So I guess the answer is what? A.
Yeah, program.
Okay. All right, so flowchart depicts programs, right? The programs in all those boxes that it refers to. Flowchart. Right here. So it depicts programs, right? Right here.
Yes.
Shows the sequence of operations within a program. All right. Looks like we made it to the end. So this is a very tough chapter, right? But what they want you to do is just have a, just a basic idea when you see different things that relate to code. While statements, HTML, XML, Java, conditions, things like that, just to have an idea of what that is about, right? And that will help you very much when you do that final exam for CompTIA. You don't have to know how to write a program, but it's a good thing to want to do. If you try to go after that kind of knowledge in school, it will be a good benefit. It's a very highly valuable skill to have in the market. Building websites, HTML, JavaScript, all that stuff. But you have to be in a school program, right, to be able to gain that knowledge in a more, should I say, structured way, in a classroom like this, but focusing on more detail about all those different subjects. Okay? All right. Let's do the attendance and let's see if you have any questions. And then you can also look at the assignment. I think the assignment should be there. Let me stop the share.